Excellent. Right, extending the PHP language with static analysis. This is one of my static analysis, and what we can do with it is one of my favorite things to be talking about. So thanks for coming along. I think these tools are incredible. Hopefully by the end of this session, you'll think that as well, and maybe you'll have some great ideas about how we can make PHP even better using static analysis. So let's start with a question. Have you ever thought to yourself, if only PHP had some language feature that another language has got? Or maybe you're thinking, I've got this great idea for PHP, if only it could do this. And this is a story where I had similar thoughts and how I built these new language features with static analysis. So it's a story where I started off with a very specific constraint, and then I moved it to something that's more generalized version that is useful in my project, but it might be also useful on your projects as well. I think ideally, you've probably at least heard of static analysis, and maybe you've had a play with SAM or PHPStan. That's probably quite useful. If you haven't, hopefully you'll still get something out of it, but I think if you've used these tools or you're using these tools, that probably puts you in a good position for this talk. So there's a few, I think there's 3 seats at the front there, just down there. And then we might have another one here. I mean, I actually have, I can start again if you want, I didn't realize we have so many people. Wow. That's right. What I might do is I might just go back to start for the people who've just arrived, if that's all right. Yep. Sorry, it's my fault. I started early. My bad. You made me start early. It's his fault, yeah. Thank you very much. Wow. The people next door think, has he finished already? Okay. Have you ever had a thought, if only PHP had some feature from another language? Or maybe you thought, if only PHP could do this. This is my story about how I built some new features for PHP using static analysis. And I started off with something that was a very specific constraint. There was a very, very specific problem that I was trying to solve. And then I extended this to a more generalized version, and maybe this will be useful on some of your projects. You'll probably get most out of this if you've used SAM or PHPStan, but if you haven't, there might be a bit in the middle that might be a bit tough going, but stay with it, because at the end I talk about things which is kind of appropriate regardless of whether you've used these tools or not. So I'm going to talk through, this is just one example I had, and it's one of many, and probably on your projects you might have a problem similar to this, or if you think about it, you'll have things that are kind of like the same, the same kind of concept really. I have some code, and I want to send a text message. So I've got some text message sender code, which is the red box, and there is a send message method on the text message sender class. Now, sending a text message relatively is quite a slow process. It requires an HTTP request. That might fail. We might have to retry. So I don't want to be calling this code from anywhere in my code base. Instead, when I want to send a message, I want to call the send message method on the text message gateway, and that we'll put it into the queue. Then we have a queue processor, which takes things off the queue processor, and then it then calls send message on the text message sender. So this is pretty standard for anything that's a slow relatively a slow thing to do. So I just want to enforce this constraint so that I don't forget, I don't accidentally call send message on text message sender from anywhere other than the queue processor. So how can we do this in PHP? What I'm saying is if I do call it from text message queue processor, that's okay. But if I call it from any other part of the code, this is not allowed. Now, if we think about our visibility modifiers in PHP, we've got public, protected, and private. None of these are really suitable for this application. There's nothing that's quite the right level of visibility. So we need to do something more. And just to reiterate, the reason we're doing this, the reason I want to automate a check for this, is because it means that either me in the future or other developers coming onto the project won't forget about this constraint. You know, we don't have to remember it in a year's time or 2 years' time. We don't have to pick it up in code review because we can just automate these checks. So this is the problem that we're going to solve by the end of this talk. And you might have similar problems to this, or you might have things that, you might have a very specific problem that's just like this, or you might have similar ones. And I think if you think about it, what we're doing here will be applicable to many of your code bases. So the journey we're going to take, we're going to very quickly look at something called the RFC process, which is one way that new features get into the PHP language. Then it's a bit of a deep dive. We're going to look at the AST, the abstract syntax tree, and a PHPStan rule, okay? That bit, quite technical. If you get lost on any of that, just wait until we come up to the peak and the PHP extension library, and then we'll finish with some thoughts. Okay, so the RSC process. PHP is open source, so anyone can contribute, and the way we contribute to get new features is we create something called an RSC, a request for change. And it's got a very specific format, and what happens is you have your idea, you create this document, so you first write your RFC, then you have a polite bit of chit-chat with all the people on PHP internals, then you have a vote, and if 2/3 of the people who are eligible to vote and think this is a good idea, it will get implemented, and then eventually it ends up in the language. Realistically, this is quite a long process, and rightly so. This isn't a criticism of the RSC process. It takes a while. I mean, I think if you had a relatively simple idea, and we only get PHP released every year, so probably the minimum time from idea to it being released as part of the language is probably 6 months, and that's if you pick your timings right and all the stars align. In reality, this is probably a longer process, and a lot of the features, sometimes they fail at the first time, and then people go round again, and it takes several iterations. So this could be like 3 or 4 years before some features make it into the language. But the great news, there is another way for some functionality. And the way is we can do static analysis. So instead of executing code, we can analyze it beforehand. So if we look at this code here, if we executed it, it would fail on this line here, where we're calling the update method on person. If we run it, we'd get this uncaught error, call to private method, person, : update. But we don't have to run this code to see there's a problem, because we've all looked at it, and we can see that there's a problem. So analyzing code and not running it, that is static analysis. And if we use tools like PHP Storm, or other IDEs, or SARM, or PHPStan, they will all look at this code, and they'll say, I can see a problem with it. So this is how we can use static analysis to find issues. And in terms of new features, using static analysis, we already have generics as part of the language. So if we look at this code here, we are iterating through whatever we get from the getPeople method. We can see that the getPeople method returns an array, and from the dot block, we've provided additional information to say everything in this array, the values should be of type person. So that means when we call process $person, we know that $person will be of type person, and then when we try and call the process method, it's expecting a car. A person isn't a car. So static analysis will tell us you've made a mistake, okay? We don't need to run this code. Static analysis can tell us we've made a mistake. So if you're not already, even if you don't want to extend the language, I strongly recommend you add static analysis to your development process. So you write code, and before that code gets deployed, you run static analysis. Ideally, well, definitely as part of your CI, but ideally as part of your process when you're developing locally. And you might say, this is great, but how does that help us get new rules? Well, we create custom rules to emulate new language features, and that's what we're going to do. So this is how we can extend the language with static analysis. We write our own custom rules, we add them into part of the things that the static analyzers analyze, and then we have got essentially new features, and they are validated at static analysis time. So that's the setting, really, of this story. Before we can write our own rules, and I'm going to talk about how to write a rule for PHPStan. It will be similar for SARM. I only know how to do this for PHPStan, but I think it will be similar for SARM. Or these concepts will be the same. But before we can write the rule, we need to understand something called the AST, the abstract syntax tree. When you've got your code, it goes through several steps before it gets executed. So we've got our PHP code. It goes through a tokenizer phase, which I don't really know much about. The tokens are then converted into something called an abstract syntax tree. Then the abstract syntax tree is used to generate opcodes, and then the opcodes are run on the PHP VM, and that's what happens pretty much every time you execute some code. You run some PHP code. And the bit we're interested in is the abstract syntax tree. So the AST, the abstract syntax tree, is a tree representation of your code base. Any PHP code you write, you can represent in the abstract syntax tree. And the AST isn't specific to PHP. Many other languages use this kind of concept as well. So if we've got some code like this class called person notifier. The AST is made up of several nodes, and each node is of a different type depending on what it is representing. So we've got a class. So this is something called a class node. And then they might have properties. So we'll come back to this. It's got flags as a property on it, which is set to 0. We'll look at flags in a bit. And this has we have some child nodes. One of them is an identifier. And so the class has got this property name, and it's got an identifier node, and that has its own property, which is person notifier. And then class also has a number of statements, and we've got 3 statements, high-level statements in this class. So we've got the property, and we've got 2 methods, the constructor and the notify player method. So hopefully you can start to see we've got our code, and we've got a visualization of it in a tree-like structure. Now, if we look at the notify player method, we've got a class method. That in itself has a name property, and again, that's an identifier, and the identifier has a property which is notify player. We've got some parameters. In this case, we've just got a single parameter, which is string, and then internally, this has just one statement, which is a method call. So the key message I really want to take from this, and we're going to look at some AST again in some of the examples, is we've got our code and we can represent it in this format. And there's a library called PHP Parser, written by Nikita. And if we ever need to do any analysis on this is the PHP representation of the abstract syntax tree. It's not actually used when we execute code, because that's all done in C. But if you want to do analysis like we're going to do, you can do this using this library. So the key takeaways is PHP code can be represented in an AST. There's different types of nodes. The nodes contain information about what they represent, and each type of node will have different information and different child nodes and different properties. So that's quite a high-level overview of the AST. We're going to keep referring back to it. But that's kind of just what I want you to take away from it so far. So let's create our first PHPStan rule. PHPStan is one of the static analyzers, and it has many, many rules. And when it analyzes your code base, it just goes through the code and tells you of any violations of these rules, and we're going to make our own PHPStan rule. So what PHPStan does is it iterates through your code's abstract syntax tree. It moves through it node at a time, and each node it visits, it says, I've got a class node. Are there any rules that are interested in this? And someone will say, yeah, me, and then it will pass off the node to that rule, and it will do some analysis on it, and either it will say, here's some issues I found, or it will return something and say, I haven't found any issues there. And then it will move on to the next node, and the next node, and eventually it's visited your entire code base, and it tells you all of the problems it has found. So to create a PHPStan rule, you need to provide an implementation for PHPStan's rule interface. And this requires the implementation of two methods. The first is getNodeType, which is pretty easy. And the second one is processNode, which is a lot more complicated. ProcessNode returns an array, and if it's an empty array, that means there are no errors. This particular rule hasn't found any issues. Otherwise, it returns an array of one or more issues that it's found. So let's create our first rule. But before we do it, let's remind ourselves what we're trying to do here. What we're saying is we can only call methods in text message sender from the text message queue processor. So we can only call the red box from the yellow box. Anywhere else in the code base, we don't want that to happen. So the node type, for our rule, we've got to say what type of node we're interested in. We're interested in code that looks like this. We've got this sender, send message, and that is a method call, okay? So we're interested in method calls, and a method call has kind of three parts to it. It is the variable you're acting on. So in this case, in this code, it's this $this sender. Then it's got the name of the method. In this case, it's called send message. And we also have any arguments we're passing to this method call. And if we look in the Nikita's PHP parser library, and we go and find the method call, at the top of it, there's these three properties, three public properties. There's the var, the name, and any arguments we're passing to it. So when we're trying to create rules, what we're trying to work out is what type of node we're operating on in the abstract syntax tree. And here we're interested in method calls. Then when you're new to this, often you're referring back to the PHP parser library, and you'll find the method call node, and there's lots more to it, but actually normally you just look at the top and you see the properties, and that's enough information to get you going. So we're going to create our rule. We will call this rule the text message sender caller rule, and there is a pint for anyone who can think of a better name for that later. So we'll implement the first method we've got to in the interface. We're saying, what's my node type? We're going to say we're only interested in method calls. So we return method call class. And then we've got to implement the process node. So what happens in the process node is PHPStan's going through its code base, and it's found a method call. And we need to see, is this method call something we need to warn people about? So the first thing we're going to do is, so what gets passed into is a node and a scope. So the node is the element in the abstract syntax tree, and the scope is a bit of additional information that PHPStan gives us in the context of this particular node that we're looking at, and then we return an array. So the first thing we're going to do is we need to know the calling class. And we get that from the scope. So what happens is, when we get to a method call, that method call could be called, that could be anywhere in the code base. We need to know additional information about it. So if we look at, imagine we had a person notifier class, and we've got this method called this sender send message, then this sender is called from person notifier. So on this method call, the class we're in is person notifier. So our calling class, if it was like code, if we were talking about the node on the previous slide, we know that calling class is person notifier. So the first thing we can do in the rule is saying if our calling class is text message queue processor, we'll just return an empty array, because that means, if we think about this, that means any call from text message queue processor is allowed, okay? So because we're only interested in finding calls to text message sender that are not from text message queue processor, if our calling class is text message queue processor, we can just exit this rule and say, there's no errors here, there's nothing to worry about. So that's this logic there. Does that make sense? That's pretty good. We are at 3 o'clock, and this is quite heavy going, I think, so well done. So the next thing is we need to know the type. So as a quick reminder, we've got the variable, the name, and the arguments, and we need to know the type of $var. So we need to know what this sender resolves to. So if we look at some code, if we've got a property text message sender, and then we're calling this sender send message, then this sender is of type text message sender, okay? So we're trying to get the type of whatever our node var is. So we're trying to work out the type, what class we're calling send message on. So that's what type is. And then, now type can be anything. It could be a primitive type, it could be, or it could represent a class, or a resource, or anything. So then we say, get me all of the classes that type could be. And the interesting thing here is, well, surely you might be thinking, surely this $sender can only resolve to one class. But actually in PHP, it could resolve to multiple classes. I mean, I wouldn't recommend doing this particular code, but here, this sender could either be text message sender or it could be WhatsApp sender. So there are times when a property or a variable could resolve to multiple classes. That's why when we say get the reference classes, that's why we're iterating over more than one. And then what we do is we're saying if the target class is text message sender, then we are going to create a rule that says you can't call text message sender from here. Okay? So what we're doing is we're working out, if we go back to our diagram, what's happening here is we are trying to call text message sender. That's the class that we're calling the method on. So if we're doing that, we need to tell people that this is a problem. And we know this is if we get this far, if we get to the red box at the bottom, and we are calling text message, if the class we're acting on is text message sender, we know this is a problem because if we were in the text message queue processor, we would never get this far because we've exited, and that's the code in the yellow box at the top. And then finally, if when we're going through all the loop of the target classes, we haven't thrown any exception, we haven't created any errors, then at the end we just return an empty array because this means that we haven't found any violations of this particular rule. So I'm just going to put the code up there with the comments. If you've got any questions, now is a great time for me to, if I need to clarify anything. Yes?
With that, I'm assuming that can't work if you've labeled something mixed.
I'm sorry?
I'm assuming that can't work if you've labeled something mixed where you looked at the different classes?
Yeah, so if this will only work if the type information is available there. That's a really good point, yeah. PHP static analysis is only as good as the type information that we have. So if you are leaning on static analysis to do this kind of thing, then it does mean that you need to give type information to pretty much everything in your code base. That's a really good point, and I shall definitely make that clearer next time I do this. So thank you very much. Any other questions? Yeah.
What about the intersection
If PHPStan can work all this out, oh, sorry, right, for the people at home, the question was, what about intersection types? And the answer is, if PHPStan can work out what the type is, then all of this will work. Okay, so we've created our first rule, and it's not a huge amount of code, actually. And this will protect us from this problem that we kind of mentioned right at the start. There's a few bits of housekeeping. Where do we keep this rule? What I do, and you don't have to do this, but what I do is I create a build directory at the same level of source and test. And then in that directory, I have PHPStan, because maybe there'll be other tools I might be using in there, like Rector. So in the PHPStan folder, I've got my text message sender call checker rule. We need to tell Composer about this. So this is just an auto-loaded dev requirement. So I tell Composer where it can find the rules. And then finally, I need to tell PHPStan where these rules are. So in the phpstan.neon file, under the services element, I say there's a class called Dave Liddament PHPStan rule text message sender rule checker, and I give it the tag PHPStan rules. So that means that when PHPStan starts, it goes and looks in its config and goes, as well as all the other rules I'm looking at, I've also got to pick up this rule as well. So I think this is pretty amazing, actually. We've not really written much code. And once you've done this once or twice, then they're not actually that difficult to create. I think this is pretty amazing. But we can do better, I think. The rule we've created is so specific, it will only ever work on that particular project for this particular combination of classes. And what maybe we could make this a bit more generic. We can say, well, look, why don't we be able to configure this so we can only call methods in target class from a specified allowed calling class? Let's make this more generic. So let's see if we can do this. So the first thing we can do is we can update our text message sender caller rule, and we'll update the constructor to take two things, the allowed calling class and the target class. And we'll just store those. So this rule is constructed, and actually probably we should change the name of it now. And then the code in the process node, there's just a couple of changes. Then instead of calling class being hard-coded, we're saying if calling class is the allowed calling class, then we'll exit with no errors. And then finally, our check for target class, instead of having it hard-coded, we have whatever we set up in target class. And then there's just a few changes we need to make in our PHPStan configuration. We now need to give a few arguments in the allowed calling class and the target class. We've got to tell PHPStan what that is. So we do that in the configuration. And that means if we want to set up another one, all we do is copy and paste the configuration, and then we have our second set of allowed classes and target classes. So now we've set up a rule that's pretty much generic. It can work for any combination of this class can only be called from this class. So I was amazed before, but this is even better. We've made hardly any changes, and now we have a rule that is, can be used even on your code bases now, or it can be used on mine in different contexts. But we can do better. So actually, there are already tools that do this kind of analysis. I think it's like PHP Arc and things like that. So if you want to do this kind of, if you want to do it just as I've said there, you've got tools which you can configure in a similar way. But I think we can go a stage further. So the problem with what we've done is we need to remind people that you can only call text message sender from the text message queue processor. So one way we could do this is we could add a comment to text message sender and say, by the way, you can only call this from text message queue processor. Nobody reads comments. We've got to remember to document it. We've got to remember to set some config up. And then what happens if we start renaming classes? If we start renaming classes, then yes, our IDEs might remember to rename things, but will the IDEs change things in the config? Maybe, maybe not. So instead, what we could do is we could create an attribute called friend. And why is it called friend? Well, actually, that's in C++, they have this concept of friend, and it means that that only friends can interact with the method call. And actually, there have been previous RSCs to add friend to the PHP language, which didn't pass at the time, but maybe they will in the future. So we've got this friend, and it just has a single a constructor with a single parameter, and that's the name of its friend. So that's the class that it's friends with. And then in text message sender, we can add the friend attribute to it and say, my friend is text message queue processor. So now we've got documentation in the code. Okay, the first time a developer sees this attribute, they might ask what is a friend, but once they know what that is, they understand what's going on here. And if we're using an IDE to do refactoring, and we refactor the name of text message queue processor, the refactoring will work. Everything will still go. So I think this is a better way of doing things. And we're starting to add like a new language feature, this friend, in attribute form, you could argue is a new language feature. And there's not really much we need to do in terms of updating, so we'll go back into our process node thing. The first thing we do is we're going to get the name of our calling class and the type we're acting on, and then we'll go through all of the classes that we're acting on. And then we've got to ask two questions. Is the target class, does it have a friend attribute? And if it does, is the calling class a friend of the target class? So we'll go back to our constructor, and we'll remove the code that we had before where we were passing in the names of the target class and the calling class. And we're going to pass in something called a reflection provider, which is provided by PHPStan. And let's go back to the code. The first thing we're going to ask is, does the target class have a friend attribute? And this is where we need the reflection provider. So PHPStan knows about the node, and it has all context for the node that you're looking at. But if you need to ask about other bits of the code base, we do that via the reflection provider. So what we're going to do is we're going to say, get me information about the target class. Then we're actually dropping down to PHP's native reflection, which we need to do because at the moment, PHPStan doesn't have its own analysis of attributes. We just use PHP's native reflections. What's really going on here, don't worry too much if it doesn't really make sense. What we're saying is we're looking at the class, and we're saying, does it have a friend attribute? And if it doesn't have a friend attribute, then we exit this iteration of the loop. And if it does have a friend attribute, then we get the first argument passed in to the constructor of the friend attribute. We just got a guard here to, if somebody didn't set this up with a friend, then we just again exit out the loop. And then finally we say, is my friend? Finally, I then get the name of my friend. So basically, if we've got this far, it means the target class has got an attribute, and we've got the name of the friend, which we store in friend class. And then all we need to do here is say, is our calling class, is it a friend of the target class? We do a comparison, and if they're not the same, then we say, you can't call this because you're not my friend. I'll share with you the repo where you can look at this again if you want to digest it in a bit slower time. What I'm going to do now is I'm going to show you a slide with all of that code on. So that is the attribute, and this is the code. I don't expect you to be able to read this here, but the point is, it is not much code. If you're sitting at the front and you've got good eyesight, you could almost read this. It does not take that much code to create the friend feature, a brand new feature. If you want to see it, that's the GitHub repo. I think this is mind-blowingly amazing. I think this is incredible, right? We can create what essentially is a new language feature in what would be a couple of hours of work. And if you compare that to the RFC process, it would be a much, much longer, and rightfully so, but it is a much longer process. So we don't have to do much, and we can create whatever well, not whatever, we can create quite a few new language features. And with custom static analysis rules and attributes equals new language features. So I think that's pretty cool. And it's because we've got such amazing tools like PHPStan that allow us to do this. Anyway, if I lost you in the deep dive, that's it. That's all your heavy concentration you need to do. It's much easier from now on in. So what I've done is actually I've created something called the PHP Extension library, which uses this kind of concept that we've done. So it's in GitHub, and there's a couple of parts to it. There's the PHP Language Extension, and that just defines the attributes. So we've got friend, got package, injectable version, test tag, and sealed. And I'm kind of developing a few more as we go along for things that I find useful. So the definitions live in this package. And what I've done is I've split them up. So if you're using PHPStan, then you want to use this extension, and that will do all the validation. Well, that has the rules that kind of implements, the additional requirements from the PHP extension library. And I've separated them out. So if people have got other static analyzers like SARM or PHP Storm, we've actually got a whole generation of people now working on static analyzers written in Rust. They can create their own validation for this. So that's why I keep the attributes in their own separate library, because then it means that even if I don't want to support implementation of it, other people can. So the friend attribute, we kind of saw actually quite a simple version of the friend attribute. The one that's created here is a bit more powerful in that you can add them to methods as well as classes. And a typical use case for the friend attribute is things like builders. So for example, maybe I have a builder or a factory, and I want to restrict the construction of objects so it's only done through the builder or the factory. So what I can do is I can say person, the construct method is a friend of person builder. That means I can call new person as long as I'm in person builder. So that would all be okay. But if I tried to construct a person from somewhere else that's not inside the person builder, like here, another class, then PHPStan would say, no, this is not allowed. And friends can be added. You can actually specify multiple friends, and you can have friends on methods and classes. And then if you've got a method and a class, then it'll add those two together. I've also created package, which is a bit like Java's package level. So this kind of sits somewhere between public and protected. And what this means is you can only call methods from the same namespace. So typically a use case for this is maybe you've got lots of code that collaborate closely with each other, and you might have one bit of it which is kind of available to the wider code base, and the rest of it is just, you should only be called by each other. So imagine we've got a price calculator, and then that makes use of a discount calculator, and we say that the discount calculator has got package level visibility, so it can only be called by code in the same namespace, in the shopping basket namespace here. So that means it's all fine to call discount calculator from price calculator, because they're both in the same namespace. But if we tried to call it discount calculator from some other namespace, then again, our static analysis would tell us off. We'd say, look, we're not in the same package. So that's package. Test tag is an idea I got from, so I did an electronic engineering degree at university a while back. And when they were testing integrated circuit boards, what they would do is they would have special pins on there, so you could get kind of like intermediate values, or you could put signals on the pins to put things into a certain state. And sometimes in testing, I think that is quite valuable. Sometimes we either want to add a method which should only really be used by test code, or sometimes what people do is they try and do clever things to expose or access what is like private or protected data. Now, I'd rather we had public methods and we annotated them, or we add the test tag to them, because that means to other developers, they can look at it and go, all right, this is clearly only here for testing, but it's not safe to remove. Or if I rename something, then I know there's a consequence in my test code. Whereas if you're trying to do clever things to kind of break through visibility, then if you go and change like a private variable, suddenly your test might fail for reasons that are not obvious. So anyway, this is test tag. Not everyone will agree with test tag. Maybe not everyone will agree with some of the things I do. But it's here if people find it useful. So if we try and call setID, so actually setID would be a use case if you've got a doctrine object and you've got something that needs the ID to be set. Normally that's set by the database. But if you're doing a unit test, you don't want to connect to a database, but maybe you need that ID to be set before you can do a test, or there's some element of testing that requires that. So we could put the test tag on the setID method, and then as long as we're within our tests, then that's all fine. But if we try and call our test code from somewhere else, then again, our static analysis will tell us off. And there's a couple of others I've done. There's this thing, injectable version, and this is for dependency injection. So what you can do is you would say, if, for example, you've got something in interface and then many concrete implementations of it, for dependency injection, you should be referring to the interface. So what we could do is we've got this emailer, and we put the injectable version attribute on it. And then what this does is it goes through and looks at all the constructor calls, and it works out all of the types of all of the parameters. And if, in this case, we've got emailer, so it looks at emailer and says, oh yeah, emailer's got an injectable version on it, but that's fine, that's okay. But if we, so that's all right, but if we have something that implements emailer, like PHP mailer, and if we try to inject PHP mailer into something, then what would happen is we look at the constructor, we say it's got something of type PHP mailer, we look at PHP mailer and say, well, that implements emailer, and emailer has got the injectable version on this. So we've got the wrong type declaration. We should be using emailer, not the more concrete version of it. So in this case, static analysis will tell us off. Anyway, if you're interested, have a look at it. The attributes are defined in the top one, the PHPStan implementation, the second one down, and others are welcome if you want to write plugins for SARM or PHP Storm. If you go into the file, the repo where the definitions are, we've got a source directory, which is where all the attributes are. And then we also have an examples directory. And for each attribute, we have like a series of example code, and it says this is where you should find problems. So if you're developing, like say a SARM or some other thing, you can look at this, and this would form your test set. And if we ever were going to debate how something would work, then actually what we would do is we'd create example codes here, and the discussion would be on here, and then finally we could go away and do the implementation. So this is like the definition of how your static analyzers should validate whether these things are done correctly. Okay, I just want to wrap up with a few thoughts. If we think about the kind of RFCs that we get, they're roughly these kind of groups. We've got security ones, so those could be, in PHP 7, they added a load of new security, they upgraded the security things. You've got RFCs, which are like syntactic sugar, so constructor promotion would be an example of that. It's not adding anything new to the language, it's just making it a bit more usable. You've got performance ones, things like the JIT. You've got new features, things like enum, I suppose. And then you've got things like communicating intent. And we'll look at that in a moment. And a lot of RFCs kind of probably overlap on some of these definitions. And doing what I'm proposing, it is really these communicating intention category that we can use static analysis to emulate new features. So if we think about things like visibility modifiers, if we think about things like final and abstract and read-only and type declarations and type hints, a lot of that is really there for developers. You know, the code doesn't really care if things are public, protected, or private. They're there for other developers. And in fact, actually having these things in here might slow down the execution because it's got to do additional checks. But they're really here to communicate from one developer to the other, or from you to your future self, that I don't think this, you know, this is public, this is what everyone should be using, but this is a private method, no one else should be using that. So they're really there for developers. And if you think about friend and sealed and packaged and injectable version and test tag, they are also there for developers. They are communicating intent. There was something at the point that code was written. I'm also trying to convey that, you know, this object, this person object, should only ever be instantiated by person builder. They're just there to communicate. And they're just there, you know, once it's documented in a way that it's automatically checked, it means that people won't forget about those checks. We don't have to remember there's some convention there. And I don't know if this will take off, but what we could have is today we use attributes like this for the friend attribute, and we try things out, and we say, does this work? You know, and maybe there's some refinements which we've got to try, and we can kind of iterate through this and discuss it. And then maybe one day, it becomes part of the language. Who knows? And there is actually a case where this has happened. In PHPStan and SARM, they had this return type of never. It's probably not very commonly used in code base, but it was there. And then that got added to PHP 8.1. So this idea of taking ideas from static analysis and finally implementing it in the language does happen. And the benefit is, you know, when you do an RFC, whatever you do, that has to work forever. Because once it's in the language, you can't make this, very difficult to make those changes. The benefit of doing this way is we can try ideas out. We can iterate through them. We can find all the silly edge cases and stuff like that. And actually, maybe if you do this and it's in, you know, people are using it for a few years, you can say, when you're creating the RFC for it, you say, look, this is where it's being used. These are all the issues we've got. Here's how we've ironed it out. And it's a much safer way of adding it to the language. So that's my journey. It started with, I have something that I wanted to do. Yes, I could have tried to get it through an RFC, but if it happened, I'd probably be talking about that in a conference in 2030. But instead, we can get this all done, and I can talk about it with you today. But the key things really are custom static analysis. They allow developers to communicate intent. They can automatically enforce project conventions, and we can use them to create new features, new language features. So PHPStan and SARM and this whole generation of tools that use the abstract syntax tree have given us developers incredible power. And what we do with that power, well, that is up to us. Thank you for listening.
Thank you, Dave. Are you taking questions?
Yeah, I'm taking questions.
Any questions for Dave?
I'm curious what you'd like to see from the language to further empower static analysis. So, for example, we've got the var type, so we're putting in comments. What could you envisage in the future that would give you more capabilities, kind of akin to how we have attributes on things?
Okay, great question. What I think the next... So, this static analysis way of doing things is great, but people have to be on board with it, you know. If you are... For it to work, you know, your project has to use it, the libraries you depend on have to use it, and if you're building something for other people to use, you know, and you've put these, you know, things in like friend attributes, it will only work if, you know, the people using your libraries or your applications also use static analysis. What I think we could do, maybe not so much at the language level, but the surrounding infrastructure, is we could probably add more things into Composer. So we could say, when I'm developing a library, this library, in my Composer definition, uses, I don't know, the friend attribute. And we have kind of a sort of definition for what friend is. So we've got an extra bit in our JSON, in our composer, and says, uses these concepts like generics, like friend, like package. And then that would be a warning, so that if somebody uses my library, when I run Composer, or when maybe that information is then available to PHPStan or Composer. When I run Composer, it says we should probably be using static analysis because this library you're depending on has said I use static analysis. And by the way, it's also said it's using this friend attribute. And if that information could then be passed through to, say, your static analyzer of choice, like PHPStan, PHPStan could say, I've got this information through your dependencies from Composer, and by the way, I think you should be using this extension because one of your libraries somewhere in your dependency chain depends upon it. I probably need to write that down, but I don't know, does that kind of make sense? So, so we're adding information to Composer, which is probably the most sensible place to put this information, and then Composer, when you do, Composer install, it says use static analysis, passes the information to static analysis, and static analysis, you need these plugins to properly validate this. I think that's probably the way it can go without modifying the language. Does that make sense?
Yeah, I was thinking along the lines of there's been very, very early discussions about allowing purely annotational data
Yeah.
within expressions, things like giving things a type and such. And it seems like one of the issues that we have at the moment is we do have to rely on things like comments a
Yeah.
lot, where we would, potentially get a lot more power if we put it into the parser, even if it was ignored.
Yeah.
But there's a lot of conflict in that's not strictly PHP's way with its runtime
Yeah.
checking.
Yeah. So if people were listening on the stream, they were kind of talking about, I suppose it's, yeah. Well, I think the attributes do answer the point because that is part of the language, and any data you supply to the attribute is available in the AST for the static analysis tools. I agree that what's really missing from it is like the generics notation. There's no sensible way of putting that in to attributes as they currently stand. I did try and think about this a few years ago, and I couldn't think of a better way of doing it. So probably what we need is, if we want to remove some of the information that's dot blocks, it's primarily there for static analysis, we want to move it into an attribute-like feature, then I think you need to either have something like an attribute feature or you change the existing attributes to support that. And I think that's another way it can, I mean, that would also be nice to be done in parallel with anything else. I think I did a gist about how you could potentially add that information in an attribute style, and some other people did some other stuff similar to that. I don't know if it's really going anywhere. I mean, pragmatically, I don't mind the information in dot blocks because the static analyzers can read that information. I mean, it would be great if the dot blocks were only there for developers, but and it didn't have any noise for that's kind of required for, yes, it'd be better if you didn't have it in the dot blocks, but I don't think it's a huge hardship at the moment, especially because your IDEs will tell you you've made a mistake in the dot block format anyway. So you get a lot of the benefits from it, even though it's in dot blocks. I don't know if I've quite answered your question or not. Or great question, though. Yeah.
I don't need that.
People at home do.
Oh, hello,
Yeah.
stream. You said it supported multiple friends, but the examples only had one. How would that look? Do you need to list each one as a separate row? Or would it
Great question. Yeah, no, you can just do hash friend. Right. The example where we went through the whole code base, our first rule, that only supports one. But when I was talking about the PHP extension library, that supports multiple. You would just do hash friend, person builder, : class, comma, person factory, : class, and so on.
Nice.
But yeah,
Thank
good
you.
question.
Any more questions?
Dave, thank you for your talk. One of the issues I found when you're using something like PHPStan is that it's becoming slower and slower. Right now our code base, it's a huge code base, but it takes almost 10 minutes to run PHPStan through it. could maybe PHP itself implement something that could help PHPStan be faster, more access to its internals or something like that that could improve this? Do you think that this is something that PHP core team should look into?
Oh, that's a controversial question, isn't it? I don't actually think, in terms of static analysis, I don't, you know, a lot of this information, well, the dot blocks don't end up in the, well, no, they sort of end up in the HT. I don't know, for static analysis, I don't know if there's much more that the core team can really do to help with that. I think this is more something that the static analysis tool vendors need to work on. And that's not a criticism of them. It's, you know, these are like quite new tools, you know, and they're just kind of, I suppose what they really need to see is they need to see examples where projects are quite slow, real life examples of projects that are quite slow. If you could somehow share the code with, assuming they'd be willing to accept that, to share the code with them so they can see why is this going slow. Because the problem they have is, you know, people say this is running slowly, and you know, how can you debug something without seeing real-life examples? So somehow you need to get real-life, slow-running examples to the static analyzer, the people who are writing these tools, so they can have a look at it and work out what is going wrong. I know some people are looking at doing this analysis in a different language, which might yield quicker results. And again, you know, the benefit of having standards for however you do things, like the generics, it's not formally written down anywhere, but everyone's kind of gone towards the same standard, and if you want to use things like this, there's a standard there. So I think that's quite important, and then it enables things outside of PHP-driven, you know, design tools to do things. So that might be another approach. I mean, I suppose actually the core team are doing, because every iteration, PHP itself gets faster, which then helps these analysis tools. So I don't really think there's much more core can do, to be honest. I can't think of any information that they could give that would help in this case.
Thank you. Any more?
Well, thank you very much, Dave.
Thank you.